Hello everyone, let's talk about Ohm's law now. So the current that a battery can push through a wire is analogous to the water flow that a pump can push through a pipe. So if you imagine that there is a pipe and then water is flowing through that. So the current is like this water, okay? The current that a battery can push through a wire is analogous to the water that is flowing through this pipe, okay? So if the water, greater pump pressure is there, so large amount of water is flowing, okay, that would lead to larger water flow. Okay, so let's say it is connected to some pump, and then that pump is pumping the water. So greater the pump pressure, more will be the water that will be flowing over here. So similarly, greater the battery voltage. Okay, so battery, the terminal, the positive and negative terminal, the greater the potential difference between these terminals. Let's say we did example last time, 12 volts for a car, and then for the flashlight it's just 1.5 volts. So greater the the voltages in the battery, that would result in more and more electron flow, and that is nothing but the current. We just learned previously that the electron flow or the charge flow is called as current. So greater the voltage of the battery, more electrons will be pushed through this wire. Okay, so how do we write this in a simple equation in mathematical form? So we say that more the voltage, more is the current. So greater the voltage, greater will be the current. So though they go hand in hand, V is directly proportional to I. We write it like this. So this is called as Ohm's law. Very simple, very easy. We call it as Ohm's law. Okay. So in the water pipe, the flow rate is not only determined by the pump pressure, but it is also affected by the length and diameter of the pipe. Now you will say that, okay, we just talked about the pump pressure. Now what about the pipe through which the water is flowing? What are its dimension? How large it is, or how small it is? How bulky it is? What's its diameter? So the flow of the water will also depend upon the dimensions of the pipe, right? Agree? So similarly, over here also, the flow of the current through the wire will also depend upon the dimensions of the wire, right? So if you have a longer and narrower pipe, it will offer, uh, you know, a, a a resistance, right? So let's say the pump pressure is very large, but the diameter is very small for that. So the water will have a hard time passing through it, right? Instead, if it is a nice bulky pipe, and then the pump pressure is again high, and then water will not have a hard time passing through that, right? So what we want to say here, that the resistance, okay, so the dimensions of the wire or your pipe will be offering, will be deciding if the flow of the water will be smooth or it will be facing a lot of resistance. Okay, so this similar situation exists over here. So if you have a longer but narrower wire through which the electrons are flowing, let's say 100 people are to cross this room, they will have a hard time, right? So they will have a lot of resistance. Resistance is the word we want to use over here, right? And to deal with this thing, okay, over here, the resistance in this case, because we are dealing with electric currents, electrical circuits, we call this resistance as electrical resistance. Okay, so whatever stop or the hard time this current or the electrons, the flow of electron is having over here, we can denote it using this term, which is called electrical resistance. So let's talk about electrical resistance. It is denoted by R. You must be aware of that. And the symbol, we use this symbol to draw in the circuit. Let's say you have a battery, you have what you have learned so far. Let's say you have this battery, and then let's say you connect it with the resistor. Okay, and then you have your load over here, something like that. So this is a positive terminal of the battery, this is a negative terminal of the battery, this is your R, and let's say this is something, some cell, okay. And this device is also, by the way, can be denoted as resistance, okay, or the load over here. So what is the relationship between them? Because we just said V is directly proportional to I. Greater the pump pressure, more will be the electrons that will be flowing through that, right? So resistance is the ratio of voltage upon current. Okay, so the voltage which you are applying through that wire, okay, upon the current. Okay, so let's try to have some insight into this formula. So when a small current is flowing, okay, so if let's say I have 10 in the denominator and voltage is same, okay, what will, let me write over here, V upon 10. So let's say this is resistance R1, but then let's say a lot of current is flowing, okay, voltage is same, and then this resistance will be different. So you do realize over here, so the resistance will be lesser in this case. So I will like to write it like this: R2 is less than R1, right? Because here the R1 will be greater. Okay. So when only a small current results from large voltage, there is a high resistance to the moving charge. Okay, so you can view this situation, you can try varying the voltage that it is very high, right? Like I played around with the current over here. If the voltage is same, the current are different, what would be the resistance, how will they look like, right? So you can try playing around this formula and get comfortable with that. So if I talk about the units now, the units of the resistance is ohms. We denote it with this symbol. We also call, it is named after the German physicist Simon Ohm, okay? So who discovered it? So very important, very easy concept, resistance. So moving on, we have this thing together now. V upon I is equal to R is equal to constant. Okay, so for a given wire, it will have a given dimensions. Okay, it will have a given battery, so how much electrons it is pumping through it, how much voltage it has, how much is the pressure, okay, and what are the dimensions. So V upon I, this resistance, it would be constant, and if you rearrange, you can also write it as like this: V is equal to IR. So this is what diagram is trying to show. So this voltage is pushing these electrons away, and this resistance is trying to stop. So these dimensions of the pipe, they will help the flow of the electron. They will help it, or they will try to resist it. Okay, now SI units we already did, they are called as ohms. Okay, this is a capital Omega. Okay, Greek language, it has a lot of symbols, it uses a lot of symbols: delta, alpha, beta. Okay, this is omega, this is uppercase omega. Like in English we have uppercase A, lowercase a. In this language we have these symbols, uppercase and lowercase. So this is not a fundamental law of nature like, Newton's laws of motion. It is only a statement of the way certain materials behave in electric circuits. So it is just defining some situations where, electric current, how it will be flowing through the wires. Okay, so what it will experience. Let's try to get our hands around it. Feel free to pause over here and try to use this formula: V is equal to IR. So the filament in a light bulb is a resistor in the form of a thin piece of wire. So you must have seen the bulb, right? And then there is something like this. So this is called as filament. So it is a resistor only, okay? It's a thin piece of wire. The wire becomes hot enough and the current flows through this, right? So this is a metal piece, and then the current is flowing. So what it is doing, it is rising its temperature. Okay, so it will become hot enough. When it becomes hot enough, it starts to glow. Okay, so the flashlight that uses two 1.5 volt batteries to provide a current of zero point 0.4 ampere in the filament, you have to determine the resistance. So what is given to us? So we are given current, we are also given the voltage. What we have to determine R, very simple. We know R is equal to V upon I. Plug in the numbers 3. Current is 0.4 and the answer is 7.5 ohms. Okay. Now you can go ahead and try to practice these questions. The first question is in circuit A, the battery that supplies energy has twice as much voltage as the battery in circuit B. Okay, so there is a circuit A and then there is a circuit B. So the circuit A, the battery that is supplying it is providing 2 volts. This is only providing 1 volt. However, the current is only, the current in circuit A is only one half the current in circuit B. So the current over here is half of the current which is over here. Okay, then circuit A presents the resistance of how much? Okay, circuit A presents dash the resistance to the current that circuit B does. So you have to basically calculate the resistance. So V is equal to IR. In this case, V2 is equal to I2 R2. In this case, V1 is equal to I1 R1. So let's divide them. Okay, and after dividing them, so we see that your V1, I can go ahead and write it like this. So because your V1 is twice the V2, so let's write 2V2, right? And this current over here, it is half of this one, the current in the second one. So let's go ahead and write that. It is 0.5 times I2. Okay, so I can get rid of this V2. I can get rid of this, sorry, this is I2. Okay, let's see what we have over here. I have 1 over 2. I have R2 on the top and 0.5 R1 over here. Okay, this is 0.5. I can do a little bit of a better job over here. 0.5. Okay, and let's try to rearrange over here. So circuit A resistance is something I'm looking for. So I will put R1 on this side and try to bring everything else on this side. So 2 will go here and then 0.5 is going up over here. Okay, so it will be 4 times R2. So it is presenting 4 times R2, the resistance. Option D makes sense. And the two circuits, question number 2, present the same resistance to the current. In one circuit, the battery causing the flow of the current has a voltage of 9. Current is this. In other circuit, the battery has a voltage of 1.5. The current in this other circuit. Feel free to pause here and write. Try to solve this question, see what is given to you, what is being asked. So again, you have one circuit, let's say it is A, you have another circuit, let's say it is B. So what's given in the circuit A, you are given V is equal to 9 volts. The current is 3 volts. So what is the resistance in this one, in this circuit over here? So I know V is equal to IR. R is equal to V upon I. So it is 9 upon 3, which is, sorry, 3, not 6. So it is 3. So I have resistance as 3 ohms for this side, for the A side. For the B side, in the other circuit, the battery has a voltage of 1.5. So voltage is given to me. So it is saying initially that they both have same resistance. Resistance I just calculated here. Let's try to write it over here because this also has the same resistance as per the question. What is the current? So let's find current. Again, we know V is equal to IR. Let's try to rearrange, isolate I because that is what I'm looking for. I is equal to V upon R. V is 1.5 divided by 3. Make sense? So you will have, let's say, 15 divided by 30. 20, that is half, so 0.5, and this is ampere. So let's go ahead and check our answers real quick. So yeah, for the first one, the answer is D, and for this one, it is 0.5 for the second one. Okay, thank you so much. This is for this part of the video, and I'll see you in the next video.